Now the topic is single phase AC to DC converters, right? So what is when we AC to DC converter is nothing but a rectifier. What the rectifier used to do? Rectifier used to convert AC quantity into DC quantity. So we are having three types of rectifiers here: uncontrolled, fully controlled, and half controlled, right? So what is uncontrolled rectifier? So an uncontrolled rectifier uses only diodes, and the DC output voltage is fixed in amplitude by the amplitude of AC supply. That means, for example, if we are going to provide, right, if we are going to provide AC supply like this, right? So in an uncontrolled rectifier, what you are going to get, we are going to get the DC output voltage as a fixed one, right? We are going to get a DC output voltage as a fixed one. For example, if it is a full wave rectifier, then we are going to get the full DC output as like this. A fixed amplitude is going to be get from this uncontrolled rectifier, and in this uncontrolled rectifier we are not providing any kind of gate signal, so that is the only reason it is known as uncontrolled. And the best example for it is diode, right? And the best example for it is what? Diode. So next, what about the fully controlled rectifiers? See, fully controlled rectifiers, these people will use thyristors for us, right? Or I can consider SCRs. And these SCRs will be acting as the rectifying elements. And the DC output voltage is a function of the amplitude of the AC supply voltage and the point on wave at which the thyristors are triggered. That means in these fully controlled rectifiers, we are going to provide what? A firing angle. We are going to provide what? A firing angle alpha, right? All these things we'll be discussing in the further coming classes, right? Next, half control rectifier, it is a mixture of both diodes and transistors. Both diodes and SCRs are going to be have in this particular half control rectifier, allowing a more limited control over the DC output voltage level than fully controlled rectifier. Anyways, these are the minimum basics you have to remember when we are going to deal with the rectifiers. So rectifier is nothing but what? It is nothing but which is used for the conversion of AC quantities into DC quantities, and we are having these kind of these types of rectifiers: uncontrolled, fully controlled, and half controlled. And one more classification we can easily go through is on the basis of number of pulses, right? On the basis of number of pulses available at the output, we can also define rectifiers as 1 pulse converter, 2 pulse converter, and 3 pulse converter, right? And also 6 pulse converter. 1 pulse in the sense what? If I am considering this as an output, you are going to get only 1 pulse, right? You are going to get only 1 pulse in the output, right? So throughout the entire cycle, you are going to get only 1 pulse. So that is the only reason it is known as 1 pulse. So if you consider 2 pulse, you are going to get 2 pulse converters, right? 2 pulses in a cycle, right? So that means what? So as it is 1 pulse, so what about n value? N value is equal to 1, and as it is 2 pulse, n is 2, it is 3, and n equal to 4 here. Understood? Or so what is the time period then? So time period is given as 2 pi by n, right? 2 pi by n. So for a 1 pulse converter, t equal to 2 pi by 1. So what about the time period? It is 2 pi, right? For a 1 pulse converter. And for a 2 pulse converter, t equal to 2 pi by 2. So that is known as pi. And for a 3 pulse converter, 2 pi by 3. And for a 6 pulse converter, t equal to 2 pi by 6. So approximately it is, the answer is what? Pi by 3. Understood? Or so this is the way of representing one thing. Understood? Or and next one is what we have to know. What about time period? So time period can be defined in this particular fashion. Another way of defining the time period is what? For example, if you are having this one, so in the output you are going to get a output like this, right? So output. So for example, this is alpha. Let me suppose we have given a firing angle. This is pi and 2 pi, right? So this is the waveform of a half wave rectifier. So the time period can be defined as, see, from this particular position you are going to get the output. From alpha to 2 pi you are going to get one cycle, one output. From 2 pi plus alpha to 3 pi you are going to get another. That means what will be the time period? Your time period will be what? Your time period is nothing but, see, from 2 pi plus alpha minus alpha. So what is the time period? 2 pi. That means what? It is time period is nothing but, right? Period is nothing but the repetition of the cycle, right? The repetition of the waveform. Repetition of the waveform will use as the period. So we'll be discussing the some more basics of this period, how we are going to calculate the time period, etc., when we are going to discuss with the R load, right? So the first topic in our syllabus is single phase half wave control rectifier with R load, right? With R load. This is the diagrammatical representation we are having, where it is A, let me suppose it is B, and Vs equal to Vm sin omega t. Vm sin omega t. Now, so at the end we are going to get the output like this, and here the I naught load current used to flow. I naught of t, let me suppose, whatever it may be, Vs of t, it is Vs of t and I naught of t, whatever it may be, right? Now, so in drawing any kind of waveform, you have to remember two important things. One, during positive half cycle, right? And two, during negative half cycle. During positive half cycle what's happening, and during negative half cycle what's happening. Understood? Or now what is going to be happen? So during positive half cycle, so anode is A is positive with respect to cathode, anode. So that means what? During positive half cycle the polarities will be like this, right? Polarities will be like this. So what is going to be happen? T is on, right? As T is on, so if at all, so this is the supply voltage Vs we are having, plus and minus, and the T is on, so that is short circuited, and then the resistor, that is nothing but what? R load here. So finally we are considering here V0. So now if you consider something, so the current used to flow in this fashion. The current used to flow in this fashion. Understood? Or I naught of t. Sorry, it's not writing. Current used to flow in this fashion, I naught of t. Now if you apply KVL here, right? If you apply KVL, so if I apply KVL, minus V0 minus Vs plus V0 equal to 0. So V0 equal to what? Vs, right? Other way of explaining here is, this is A, this is B. As it is short circuited, so this A is appearing over this A, this node, and this B is appearing over this node. That means what? V0 equal to how much? VAB. VAB is nothing but what? Positive Vs. In this manner also you can derive. Understood? Or what I am saying? Yeah. Next, in the negative half cycle, right? In the negative half cycle, what's happening? So this is the condition. In the negative half cycle, the polarities are going to be changing. So VAB becomes VBA, right? Polarities are going to be changing here. So definitely minus has been attached to the anode of the thyristor. So definitely it is an open circuit. And here I naught of t used to have, and this is what? R load, right? So if you clearly observe, as we are going to take the output at this condition, V0 equal to I naught into R, right? V0 equal to I naught into R. What am I going to say from Ohm's law? But as there is an open circuit, what about I naught? I naught equal to 0, right? I naught equal to 0 amps. So thereby, if I substitute this value over here, what is V0? V0 equal to 0. Understood over these two conditions? So you have to remember what the things are. During positive half cycle what is happening, and during negative half cycle what is happening. That's it, right? During positive half cycle what is happening, and during negative half cycle what is happening, right? So let us concentrate on waveforms of single phase half wave control rectifier with R load, right? Yeah. So what are the main basics we are having? During positive half cycle, V0 equal to Vs, and during negative half cycle, V0 equal to 0. V0 equal to 0. So let me draw the waveforms, right? See, clearly I am drawing the waveforms here. So consider this as what we are having the axis, right? This is the condition. Yeah. So we are having a supply like this. Understood? Over? We are having what? A supply like this. Now what's happening? Now what's happening inside the thing? Understood? Over? Let me wait for a while. Let me change the pen color. Yeah. Now what's happening? At alpha, this is what the alpha condition. At alpha, I have provided triggering angle, right, to the thyristor. Alpha pi, this is 2 pi, this is again 2 pi plus alpha, this is 3 pi, this is 0, and this is nothing but what? Supply voltage Vs. Now at alpha, when I have been triggered, so this is v0 of t value I have considered, this is Vs of t, right? So at alpha, what is going to be happen? So during positive half cycle, this is the positive half cycle, v0 equal to Vs. So the exact replica is going to be happen. So firing angle after giving some kind of triggering angle, so exact replica is going to be happening over this. Understood? Over during positive half cycle, it is v0 equal to Vs, and during negative half cycle, what about v0? It is 0. And up to what it is 0? Up to again, until or unless we are going to trigger in the next cycle, then it will be 0. And now you tell me, during again it is positive half cycle, and during positive half cycle we are going to get the value as v0 equal to Vs, right? Here t is triggering, here t is under on position, this is omega t value. Understood over what I am saying? Now if you consider one thing here, so this is what you are having, and I told you in the previous class, I told you before in our live sessions, both voltage and current will be in phase for a resistive load. So that means the current will be like this. The current will be like this. So this is nothing but what? The current value I0 of t. Please go through the PPT or slides which I am going to provide you when you are going to watch this particular video, right? So I0 is nothing but what? V0 by R, right? Now this is alpha, this is pi. You try to mention all these things. Now if I am going to provide, if I am going to talk about the voltage across the thyristor, right? Voltage across the thyristor, then what is going to be? See, voltage when the thyristor is conducting in this period, definitely the thyristor voltage is 0. So here it is 0. Understood? Over. So before it is going to be there is some kind of voltage up to alpha, and later on it is 0. Up to pi it is 0, and then you are going to have the voltage up to what? 2 pi, and then alpha to pi. The reason is what? In the negative half cycle, the v0 is 0, but there is the voltage across thyristor, and from 2 pi plus alpha to 3 pi, again the thyristor is conducting. So that is the only reason we are having v0 equal to vt equal to 0. So this is what vt. Understood? Over. So this is the simple way of explaining the waveforms of R load. Understood? Over. Fine. Thank you.